So today we're going to have a look at direct current motors, otherwise known as DC motors, and we're going to try to describe how these type of motors work. We're going to then give a description of their various parts. We're going to focus on one important part of the motor, which is called the commutator and the role that it plays. And then we're going to have a look at different types of DC motors, just how they're made and why, the functions that they would serve. All right, so here, let me just do this. In this diagram here, I just have a simple image of a DC motor. Now I want you to ignore this voltage output just for the moment. And what we have here is we have a motor. And I want to focus on the current. So here I've got positive and negative terminals. It means my current is flowing in that direction. And that current then flows into this section of the motor through the wire. Let me bring it back if I can. Through the wire. And that current would have a direction like so. When it comes around this loop, and this section here with the red and the blue is called the loop, what we'd find is the current is coming in the opposing direction to the red section. Now, we want to apply our right-hand palm rule or our right-hand slap rule to this. So our right-hand slap rule is going to say that the direction of our fingers should be matching up or running parallel to the direction of the magnetic field. So that's the magnetic flux moving from north to south. So our fingers should be in that direction. Current should be orientated in the direction of our thumb, or our thumb should be following the current. Therefore, if I focus on my red section here, what I get is a downwards force. Alternatively, when I have a look at my blue section, remember field there with my fingers, current following the thumb in the blue section, so the thumb should be pointing towards, out of the page. And then I have an outwards force going upwards. Now, if I think about this in this direction, one part of my motor, I've got a downwards force, and the other part of my motor, I've got an upwards force. And what this creates is a rotation. And our rotation is what we call our motor. So it's moving around in a rotatory fashion. And we actually call this our rotor. So the loop here is also known as the rotor. All right. And we can see in this diagram previously to our explanation, it says that the axis of rotation should be following this direction, which is anti-clockwise, and that's because of the way that the current is interacting with, or the current around the loop is interacting with the magnetic field. Alright, so that's a very basic understanding of how a DC motor works. If we have a look at parts of a DC motor, so what we have is obviously we have our magnets. Okay, now they call it magnetic field. We could call it, or magnetic flux, we could call it magnetic field. This red and blue section is one wire, and we call this the loop. In here we'd have an axis, and we call this the rotor. Now sometimes the loop is also referred to as the rotor because that's the sections that is rotating. And this important section here, this is a very important section, is called the commutator. Okay, and that's a specific type of commutator. And obviously we have here our source. So our source is an electric circuit. It could be a battery that's wired to the commutator in a specific configuration. Okay, and that's our electrical source. Don't worry about this voltage output here. So they're the main parts that you need to understand, or you need to appreciate when you're doing it. Probably the two key elements that you want to focus on is the commutator, the rotor, the source. Now this commutator also has carbon brushes, and these carbon brushes are shown by these little grey areas just in here. They're our carbon brushes, and we'll explain why the carbon brushes are like so a little bit later. Okay. So what I want to have a look is what happens with the commutators. So if I look at this commutator just on the left, so this is a commutator with carbon brushes, it's playing in a specific role, all right? And the role of a commutator, so a commutator, okay, it reverses the current in the loop, or sometimes you can say or rotor, okay, to ensure the rotor moves in one direction, whether that be clockwise or anti-clockwise. In both of these examples, they're moving anti-clockwise. So if we think that we always had a current flowing that was always on this side flowing that way and always on this side flowing that way, then we would get always upward motion here, downward motion there, and we get a continual, if you like, rotation of our motion. And what the commutator is actually reverses the current to allow that. So what the commutator is specifically doing is making sure that this side there's always positive current flowing in that direction, and this side we've got positive current flowing in the other direction. And it makes sure that that's always happening with the motor, independent of which way it's orientated. So the way that it does it is, obviously you have a positive and negative terminal here, okay, and these carbon brushes are sending that electrical current into the commutator, which is moving around, okay, moving around like so, coming to positive, negative, and that keeps the motor functioning in that direction. Okay, so that's a commutator with carbon brushes. But here we have what we call a split ring commutator, and this split ring commutator is doing the same thing, okay, keeping positive current here, negative current coming out of there, so that keeps our current flowing in that direction, down here, up on this side. And what it does is it makes sure that the current, it keeps on flowing. Now, the reason why we choose split rings over, if you like, just a simple commutator with there, is you don't get this gap, and you can ensure a better connection. So sometimes split rings are, if you like, split ring commutators are more efficient in moving the motor around as compared to just a simple commutator with carbon brushes. Okay, so you're going to have different types of DC motors. So this is what we would call a very simple DC motor. And what you would find here, if I spoke about, if you like, the rotation speed, of the motor, what you're going to find is you're going to get, you know, very high speeds at some speed, and then they're going to dip, and they'll be speeding up, speeding up, speeding up. And this is sometimes referred to as a shunt motor because it's sort of like, it's z, 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 z. It's moving around, but the reason why is because you got maximum force on this side, but when this sort of tilts a little bit, so we have our loop like so, and there's a little bit of a tilt in how it's functioning, like so. Well, the speed at which all the forces that are working on the motor, they start to decline a little bit. So one thing that you can do is you can put in a second wire that may run like so, and you could even put a third loop, fourth loop, and keep on putting them until it becomes sort of like a coil. And what you get with a coil motor, okay, is you can get continuous output. So your rotation speed, which is more or less your output, can be retained, and it becomes a little bit more stable. You're not getting that shoot happening like you would in a shunt motor. You're getting the nice bzzz with everything just rotating, spinning around. And you can find examples of this. I'll put a link into the YouTube video just in the description, so you can have a look at why we would put a number of loops into a motor. All right, thank you.